Welcome guys to my YouTube channel. You are back again on the H2O channel. Today we are going to be taking an intense revision on atomic structure and chemical bonding. By the time we are done with this question, we are still going to look at other questions again, okay? So please, I want you to be very attentive to this particular question because they are very tricky problems. Now let us start with question 1. When a pure aluminium metal is heated to red hot in the presence of nitrogen gas, the compound formed is what? Now, they meant that solution to question 1, that aluminium is to combine with nitrogen. Aluminium is to combine with nitrogen. Now, when you want to combine two elements, you must make use of their valency. Now, first of all, what is the valency for aluminium and what's the valency for nitrogen? Okay? Now, if you want to combine these two elements, you must know their valency. And knowing their valency, you must know their atomic number. Okay? If you check very well, you will find out that for aluminium, the atomic number is 13. And for nitrogen, the atomic number is 7. Now, if we distribute this atomic number into the KLM shell, remember, if an atom has 8 electrons or an atomic number of 8, if you are working with the KLM shell notation, you will have to put 2 here and then you put the remaining 6 here. That makes it a total of 8. Now, what becomes the valency of this atom that has an electronic configuration of 2 and 6? Okay. Now, in the combination of elements, your highest valency is 4. So, if you have 2, 6, it means that you have to look for a number that you will add to 6 to give us a total of 8. Or you have to say 6 minus 4 to give you the valency. Okay. But it is safer to say that since you have a total in the periodic table, you have group 8 as the last group of the periodic table, or valency of 8. You can say 8 minus 6 to give us 2. So the valency of oxygen atom is 2. Okay, if I give you another element like chlorine, chlorine is the 17th element of the periodic table, and that will give us 2, 8, 7. If you have 287 as the electronic configuration of chlorine, it means that the valency will be the number that should be added to the last number to give us a total of 8. So if I have 287, what will I add to 7 to give us 8? It is what? 1. So because of that, the valency of chlorine is equals to 1. Now, for instance, if I'm talking about a metal, let me say, for instance, I'm talking about a member of group 1, group 2, or group 3. Let's take, for instance, sodium. Sodium is the 11th element of the periodic table. What is the valency for sodium? Now, if you use your electronic configuration, you have 2, 8, and 1. That will give us a valency of what? 1. Okay? If I take another element like magnesium, magnesium is the 12th element of the periodic table. So what we have is 2, 8, 2. So the valency of magnesium is what? 2. Now if I take another element like aluminium, which is what we have here, you have 13. It's number 13 in the periodic table. So you have 2, 8, 3. The valency is what? 3. Now if I take an element like carbon, carbon is number 6 in the periodic table. That will give us 2, what now? 4. What's the valency of carbon? 4. But if I take an element like nitrogen, which is number 7 on the periodic table, that will give us 2, 5. Is the valency of nitrogen equals to 5? No. Okay? So what do? You simply do this. What will I add to 5 to give me 8? And that number is what? 3. It therefore means that the valency of nitrogen is what? 3, not 5. Do you understand? Now, watch this carefully. If we have from group 1 to group 4, their valency is the electron left in the outermost shell. But from group 5, group 6, group 7 the valency is the number that should be added to that valence electron to give us a total of 8. So for nitrogen, because you have 5, you don't take 5. You look for a number that you add to 5 to give us what? 8, which will give us a valency of what? 3. That's what I told you in the case of oxygen. Oxygen is number 8 on the periodic table, so it is 2,6. Is the valency of oxygen equals to 6? No. What will I add to 6 to give us 8? 2. So the valency of oxygen is what? 2. That's good. So let's quickly answer this question. If the valence electron starts from 1 to 4, you can take it as the valency. But if it is 5, 6, and 7, you have to look for a number that should be added to the valence electron to give us 8. And that number becomes the valency of the atom. So as for aluminium, you have 2, 8, 3. What's the valency for aluminium? 3. For nitrogen, you have 2, 5. Is the valency equals to 5? No. You look for a number that you add to 5 to give you 8, and that number is what? 3. It therefore means that the valency of nitrogen is what? 3. Now, if they want to combine, elements usually combine by their valency. So if I write for you aluminium, the valency will be 3. If I write nitrogen, the valency will be 3. So they will both cross this way. They will exchange their valency so that the formula of the compound becomes nitrogen will carry the 3 give aluminium. Aluminium will carry the 3 give nitrogen. So it becomes Al3, L3. So because these two numbers are the same, you can cancel them out so that you are left with Aln. This is the formula for aluminium nitride. So you can check the options and see the answer for yourself. The answer is not A. The answer is what? B. Wow, that's quite interesting. Now let's quickly take the next question. Let's quickly take the next question. Question number 2 says, an element X and Y have electronic configurations of this and this respectively. When they combine, the formula of the compound is what? This one is quite similar to this, okay? It's just that the electrons here are given in terms of the SPDF notation. Oh yeah, let's quickly answer this question. Now, for X, they told us that it is 1x2, 2x2, 2p4. Now, if you want to know the valence electron, or you want to know the valency of this atom, what do you simply do? You have to add all these numbers together and put it in their KLM shell. So if you check very well, you will see that this is 2 plus 2 to give us 4 plus 2 to give us what? 8. And if you already have 8, use the KLM shell to distribute 8 electrons. That will make us to have 2, 6. And if this happens, because 2 plus 6 will give us 8. And what we are using is the KLM shell notation. Therefore, the valency of this particular atom, which is S, will not be 6. No, I told you that if the number crosses 4, if it is 5, 6, or 7, you look for what to add to the number to give us 8. So if you check very well, you have 6.